Hello and thank you so much for having me. I'm delighted for giving us this opportunity to present our works. I am Yunus Mohammed, PhD student from University Mansouri Constantine. I will be giving a short presentation on silicon solar cells performance in Algerian deserts. My presentation is divided into four main sections. I will start with the introduction, then I will look at method and materials, next results and discussion, and finally conclusion. The main contribution is to provide a concrete set of answers to the questions that must be addressed in order to understand the challenges related with operating PV and to improve the economical output of photovoltaic power systems in Algerian Sahara. The evaluation consists of EV curve measurements and visual observations. Tested PV modules have been subjected to extreme weather conditions above 63 degrees and exceeds 1000 watt per meter square, and sandstorm for over 11 years. Increase in cell series resistance and physical material defects have mainly contribution in failure of polycrystalline solar cells. In the paper, the analysis of early degradation will start by analysis of the most harsh conditions of the desert climate, then take out the results. Introduction. First of all, I would like to give you an overview on the most famous questions about the photovoltaic solar panels deployments in Sahara regions. The first question is why the Algerian Sahara is an attractive area for the PV module deployments. The environmental challenges who affect the performance and the behavior of electrical parameters of PV modules in Algerian desert regions. The most commonly observed failure modes in desert environments, and finally, the challenges associated with operating PV in desert climates and the performance assessments and degradation analysis of silicon solar cells in Algerian Sahara for over 11 years of exhibition. Answers for the questions. The size of Algerian Sahara could capture enough solar energy to meet the entire world's electricity needs. Moreover, Algerian Sahara region seems optimal for PV deployment. These reasons make them very appealing targets for renewable energy programs, particularly in the solar energy. These regions incorporate all the requirements for successful and sustainable investment, among which are the long and high exposure periods and the high UV levels, specifically in the summer seasons. The analysis of data from Table 1 confirms the assumptions about Sahara region climates. However, is extremely hot, dry, and expressing very pertinent thermal variation between day and night. The performance of photovoltaic modules in hot desert climates depends on various factors like cumulative solar irradiation, high operating temperature, accumulation of dust, etc. In hot desert climates, solar cells are exposed to harsh climatic stress factors like heat and dust experienced. These conditions pose a challenge for the optimal performance of solar cells. Therefore, it can take few years to degrade and or to fail in the field. In literature, these represent the most difficult environments for PV module. Exposure of solar cells to high UV combined with heat is causing changes in thermomechanical properties of EVA as well, and affect thermomechanical fatigue in interconnection. Therefore, the most commonly failure modes in desert environments are discoloration of EVA encapsulant accompanied with delamination above the cells and certain degrees of cracking and or deterioration of the solder bonds. Thus, discoloration of EVA results in formation benzoic acid and phenol products which enhance delamination and discoloration. I would now like to move on to the next part, method and materials. The platform experience was carried out at URERMS Adrar in the extreme southern of Algerian regions to understand the challenges associated with operating PV in desert climates and to assess the PV cells performance in this climate. Many PV modules have been tested in field. These tested modules were exhibited for over 11 years to the harsh conditions of Algerian Sahara climate as heat and high UV. The evaluation of degradation rates is one of the important cases that has been used to assess the output power group. Material used. 6 polycrystalline modules have been tested in field. The tested modules consist of 36 polycrystalline silicon cells with a maximum power of 50 watt grades. The thermocouple attached to the backside of PV module is used to measure the individual temperature. Simultaneously, solar irradiation measurements are performed by a pyranometer. Measurements have been performed after midday when the sun is at the. I would like to discuss in more depth the implication of environmental challenges, particularly the effects of temperature on electrical parameters of polycrystalline silicon solar cells and the early degradation in Algerian Sahara by analysis of data environments during the summer season. The Sahara climate is characterized by very hot and dry days accompanied with high UV solar irradiation, especially in summer season. As figure 1 shows the temperature variation during the summer season of the year 2018. The average max temperature stays stable between 37 and 41 degrees and reached the highest level 48 degrees in July. The highest temperature has been recorded in summer environment 50 degrees as illustrated in figure 2 from table 1 and figure 1. Table 1 presents climatic data for summer season in region of Adrar, Algeria. As you can see, it illustrates the 4 months of summer from May to September, with all the data recorded as the maximum and minimum average temperature, rate, humidity, and maximum average of rainfall. Let's now turn to the relation between ambient temperature and the solar cell's temperature. In field, the solar cell's temperature is basically correlates with ambient temperature according to the Feynman model used to evaluate the cell temperature of PV modules under outdoor conditions. Therefore, in desert climates, any variation in the ambient temperature are mainly responsible for significant increasing in the cell's temperature. The variation in ambient temperature between maximum and minimum values at useful period are illustrated by figure 1-2. As the region characterized by hot and dry climates, the outdoor operation of PV modules on a day-to-day basis increases thermal stress. The cyclic thermal stress leads to fail, such as the fatigue cracks at the solar interconnection, which in turn increasing in the cell series resistance of a PV module. The third part, results and discussion. From the results obtained from the experience, we can translate on 4 charts. The first chart illustrates the figure of efficiency. From overall observation on the output power, the efficiency of tested PV module in field decreases in overtime. Some modules lose more than 37% of their efficiency. The average degradation rate efficiency of tested PV module in desert climates is over to 30% in 11 years field. The degradation rate expressed by 2.73% per year. The warranty of PV module is expected to be over 25 years. Typically, 90% of the initial power output is warranted for the first 10 years, where degradation rate expected by 1% per year, while 80% of the initial power output is accepted for the first 25 years. Comparing to the obtained results of tested module, results shows that the tested modules have been known to significant degradation rates that conduct to early degradation in field. The second chart Series resistance. The series resistance values of tested modules have shown significant increasing in 11 years field. The increasing rate expressed environ 170%. The RS of the PV module arises from the resistance in solder joints, cell metallization, and cell interconnect busbar. The increasing of RS reduces the voltage produced by the photovoltaic panel to the hot desert climate conditions, such as the heat combined with high UV irradiation. The thermal stress conducts to fatigue cracks at solar interconnection that lead to increases the series resistance of tested PV module. This results in an overall drop in the power generated by a PV module. The results shows that significant variation in series resistance have mainly contribution on early degradation and the power drop of polycrystalline silicon in desert climate. Shunt resistance. The shunt resistance play an important role in the electrical performance of solar cells, as illustrated on Figure 5. The value of tested modules have shown decreasing in 11 years field. The decreasing rate expressed environ 65%. This degradation have contributed on decrease of current. Field factor. Results from Figure 6 show the influence of both shunt and series resistance on the field factor, hence on the performance of solar cells. Conclusion. In the conclusion, let me sum up my main points. Due to extreme conditions and different internal stresses of Algerian Sahara Desert, polycrystalline cells are degrading before meeting the manufacturer's warranty of 25 years lifetime. Based on the results presented in this study experimentation, revealed that the early degradation and failure modes of the polycrystalline modules is highly depends on the environment conditions and the material used. Long-term reliability and the optimal performance in desert climates could be accomplished by changes in material properties. Reference. That brings me to the end of my presentation. Thank you for your attention.